statistical package we are going to talk about. And uh, regarding my area of interest is I really have two broad categories where I always like to keep on my study, keep on concentrating on issues related to problem. One is natural resource management, particularly water and forest, how to value forests, how the ecosystem services it provide to the economy, and how to capture the most ecosystem services that forests are providing, water are providing. That part. The second, and related to that, the conflict that arises. It's a kind of a man-nature conflict. It's a kind of a man-man conflict, man versus man conflict, and we have several literature on these issues where the game theoretical approaches are applied in those areas, in certain areas of that. Apart from that, I have a kind of a liking in dynamic macroeconomics, like the movement of the economy, the health of the economy over time, how it grows, how it behaves, and what are the factors, what are the internal factors, what are the external factors, importantly, shaping the economy and in its achievements and so on and so forth. So here we have gathered to discuss on a particular type of package. Before that, I would like to tell that most of you maybe are the postgraduate students and scholars, research scholars. So, as a researcher at any level, be it a graduation level, be it at a post-graduation level, be it at a PhD level, I mean, as a researcher is always a researcher. And everything starts on a particular one word, that is thinking. If you have a good thinking process, then you will read and then think. So these packages, these statistical packages, they will actually help you in calculations. They will calculate on behalf of you, and the result that you will get, you have to interpret the result as a researcher. The models will be there. You have to conceptualize the model. You have to find out the variables. You have to find out the scales in which the variables are going to be measured. And after that, the model that will be calculated, the way you will incorporate the data in a statistical package, it will take maybe 10 seconds to calculate the result. Your job after calculating the result, your job is to interpret that result. Okay. Now that interpretation has a kind of a platform where your literature review, the review of the past studies that has already been done by other researchers in the same field, that is going to guide you that, okay, fine, I have this kind of studies that I have already gone through. And on the basis of that, I can say that this theory is there, so I can check the theory in my case, in my study. Otherwise, it is possible that you can see that completely new things are coming out. Now, if the new things are coming out, which is not supporting the theory, you have every possibility of explaining that theory in your own way with a solid logic. Now, again, that logic a researcher can develop only when he or she has a very clear cut understanding about the review that he or she has completed before conducting the research. That means this review of literature is actually going to help you to build your own concept about the particular topic. At the same time, it is also going to tell you the stories about the different dimensions that has already been captured by researchers in the same field. So there are two different types of benefits of this. So once you have that, then you are in a position to interpret that, interpret the result that you have got from the data analysis. Now, you know that data is important. Why? Because we need to develop some kind of a problem that is a real life problem on the basis of the available literature, available theory, available analysis that is there on the particular topic. And Maybe from that you have some way or other you have found out a research gap that okay fine, this theory is available there, this kind of dimensions has already been covered by the theory, by the researchers, but maybe I find out somewhere it feels like that a particular area has become untouched, so I'm just going to incorporate that in the existing literature. That is the job of a researcher. That is what it is actually all about. Okay, now here in this particular session, we are going to talk about a particular statistical package. You have a lot of packages available right now. Some of the packages for which you have to pay money. Some of the packages are also there for which you don't need to pay money. They are free of cost. Now, out of the packages for which either the individual or the institution need to pay money to purchase, the mostly used one is an SPSS. So let us go to that. I have quite a number of slides, but trust me, I know you're always already you have gone through a long session, so I will try to keep it as short as possible. Okay, uh, let us see. Um, am I audible? Am I audible?
Yes, sir. Yes, sir.
Okay. Thank you so much. Mm, your interest screen. Okay. Okay, so we have something. So now I think I am not visible. The slides are visible. Slide is visible, right?
Right.
Okay. So we have a presentation which is going to talk about the very basics of SPSS. Now, what is the objective of this particular presentation? We want to describe the opening and closing of SPSS. SPSS is a software which is definitely user friendly, but it follows certain customs. So we need to know that. To introduce the look and structure of SPSS, to introduce the data entry windows, that is the data view and variable view, to outline the components necessary to define a variable, and if possible, we will go through the very basics of a regression analysis, because our I thought initially that maybe a diagrammatic representation is better, maybe how to create table is also better. Then I thought that this life is a complex kind of platform where we always deal with more than one variables at a time. So if we take a kind of a situation where more than one variables are there and we have to deal with it, then it's always better if we go for a kind of a regression analysis and just want to see that how a regression is done using the statistical software, particular statistical package for social science. That is SPSS. What are the uses for SPSS? We generally talk about data management. We generally talk about data analysis in SPSS. Now, the thing is that here, that maybe a researcher is working on a data which he or she is collecting for the particular kind of research. That means we are talking about a primary data. Okay. Now, the primary data that one has collected, shall we present the data as it is in our study, in our report, or in our paper? No. Even when we talk, the talk needs to be meaningful. Unless and until it is meaningful, it will never reach the audience. Similarly, when we are going to represent a data, we always have to remember that that data, that particular set of data, has to be applicable and publishable in nature. Then only it can reach the audience. So data management is a very important part that includes the data entry and data purification issues. And then when you have a data which you have already managed, then you have the analysis of data. That is the second part, data analysis. What we have in data management means what? Data management means definitions of variables, defining variables, coding the values, entering and editing data, creating new variables, recording variables, and selecting cases. Okay, so these are the parts together. Taking all this, we mean what data management actually is. Similarly, data analysis talks about the univariate statistics. You might have a data that has already been collected by you, by the researcher, by the institute. Maybe it's a secondary data collected by somebody else, some other organization, government agencies. They are available publicly in websites, in government reports, in libraries, in institutions like the universities or colleges or whatsoever it may be. It can be in univariate data where only single variable concerned is important to the researcher. It can be bivariate data where you are interested about two variables and their relationships. And it can be multivariate data where large number of data are there and you are interested, as a researcher, you are interested about the relationship that is there between two sets of variables. One is dependent, the other set of variables are independent. What kind of relationships existing between these two sets of variables? Okay, so we have different types of statistical measures for univariate data, bivariate data, and for multivariate data. These two basically, bivariate and multivariate, they are of same categories because just remember that the easiest and the simplest most case, multivariate case, is bivariate. If you are not considering one variable, then in the simplest way you can consider multivariate analysis in terms of two variables, where one variable is attached with another variable, maybe one dependent variable and one independent variable. Okay, so that is all about the data analysis discussion part that we have. So let's start with a kind of opening of SPSS. So you can, if you have a SPSS icon, then double click the SPSS icon on the desktop, or otherwise go to the start, then program, go to the programs, then SPSS for Windows, then SPSS, click on that. The following introductory screen should appear. What should be the screen? This will be the screen. That is the opening of SPSS. So SPSS for Windows will appear here. It looks like this. SPSS for Windows. What would you like to do? Run the tutorial, type in data, run as existing query, create new queries using database wizard, open an existing data source. Files will be there. Then after that, you go to the data view window. This is the data view window. Okay, it looks like an Excel spreadsheet. You see that there are similarities. We have files, edit, view, data, all the tabs are there. So if you click on any of the tab, then the drop down will come and you will be having more and more options on that. And like a spreadsheet, we also have different columns and different rows. So these are similar to the Excel, like these two. This cell is having a column name as well as a row name. Okay, this is how it looks like. Yeah. So this is actually the cell edit field. This looks the cell edit field. This is the view tabs. You have two views here. One is the data view, the other one is a variable view. Okay. Then you have a cell information. So these are the cell information will be available here in the leftmost kind of a cell that is here on the left top corner. Yeah. This is known as a status bar or box. Status bar or the boxes that is there, that is also available in the data view window. Now in the data view, the rows represent cases or observations. That means if you are thinking about, if you are considering respondent 1, the first respondent, then The first row will represent the first respondent or first case. Second row will represent the second case or the second respondent. Third will represent the third case or the third respondent. Similarly, the objects on which data have been collected. That means here again, you have different variables. Let me tell you that in any kind of research, you have to make a plan of the research. That means you have identified a problem. You have set up a set of objectives. You have also gone for maybe the hypothesis, the statements that are going to justify your objectives. So your job is to test the statements, that means the hypothesis, on the basis of the data that you are going to collect from the samples, that means the representative populations. Why we are talking about samples? Because as an individual researcher, it is not possible to collect data from each and every member of your target population. If we are planning for conducting a research, conducting a study on the the number of primary schools in the entire state, it's not possible to visit each and every primary school and to collect data from those each and every of them, because this will be time consuming, this will be costly, this will involve a lot of people. So your research will be absolutely costly if you go for each, collecting data from each and every member of the target population. So what we do, we generally pick up the representative of the target population. And there are methods. You know that they are known as a sampling method. There are different types of sampling techniques. It can be a probability sampling technique. It can be a non-probability sampling technique. So out of using those techniques, you will collect some data, and the data that you are going to collect for each and every member, for the first member, this row will incorporate the data for the first member. Second, this row will incorporate the data for the second member. Similarly, for each of the members, there is a variable one, so you need to know about the responses for variable one from maybe 100 individuals or 100 cases. So these 100, there will be 100 rows against this variable. For the second variable, again, you will get 100 cases or 100 individual responses. For the third variable, so on. And the number of variables you are going to have for each of them, if you have 100 respondents, you are going to get 100 observations or 100 responses for each of the variables. For example, rows represent the contents of a single treatment data collection form, the information on an individual. Rows represent the contents of a single treatment data collection form, the information on an individual. Particular row, as I said, particular row is talking about the information collected from a single individual. Columns represent variables or characteristics of the object of interest. So we are interested about a particular characteristic, we are interested about a particular variable. So that variable will be actually pointed in terms of a column heading. And the column, that means for a particular variable, the responses that will be obtained from different individuals, maybe 100 individuals, maybe 150 individuals, maybe 200 individuals, according to the size of the samples that the researcher has finalized, will be obtained in particular column against different rows. Okay. For example, each column contains the answers to the questions on the treatment data collection from age, gender, primary drug of use, etc. That means if a kind of a dependent variable has been selected as a treatment, we are interested about treatment of a patient, then we are also interested about the case history of the patient. So we need, sometimes doctors used to write what is the age, then the gender, then any kind of primary drug of use is there or not. So this kind of variables will be there. And this kind of variables will be like age, gender, primary drug of use. This first one may be the treatment. The second one may be the age, the third one may be the gender, the fourth one may be the body weight of the individual, the fifth one may be the use of primary drug or not is there. So these will be the variables, and accordingly, from the responses, from the respondents, the researcher will get the responses, and the number of sample, the sample size will decide that how many rows will be there under each of the columns. So that is a data view. Now, what is the role of a data editor? A data editor comprises of two screens. One is data view, the previous screen that we have seen. The other one is a variable view. That means it's not that you have just clicked on the variable on the area where you cannot click here. That is not possible. Okay, so for that you have to go to a variable view. How? Variable view we use to define the variables. That means to move between the two, use the view tab at the bottom of the screen. Use the view tab of the bottom of the screen. This one. Or Control plus T, or view variables from the data view window, or view data from variable view window. So this means this is a data view window. See, this data view is open. So if you click on here, this variable view, then instead of data view window, the variable view window will open, will come up. Okay, that's how you will start. See, this is a variable view. Once you click on this, it was earlier it was data view window, now it is having a variable view window. Now in a variable view window, see name, type, width, decimals, levels, values, missing data, columns, alignment, measures, all these things are available. What does that mean? It means that the variables that you are going to incorporate in the SPSS, this is the data view. So if you have, once you have the entire data set with you, the variable names will appear here. And the corresponding responses that you have obtained from the different individuals will be appearing here. Okay. But before that, you have a job. Job is that you have to write the name of the variable, then what type of variable it is, then the width of the variable, then whether you are considering at all about the decimals or not, the levels you have to put. Okay, so these are the things that you will find out initially when you have a variable view window open. So from variable view window, if you want to go to the data view window, you can click on this data view. Readily the earlier window that we have seen in the last to last slide, that will come. Then you have another issue, that is the data entry process. Now how to enter data? First you have to define your variables in the variable view window. Okay, that means you have to define your variables here. Remember, SPSS is going to help you in data management and data analysis. If you put them correctly, it will give you accurate result. If you put them incorrectly, it will again give you accurate result which is completely incorrect. So it is not that you will put any kind of data and the result will be fantastic and the excellent result will come after that. That is not going to take place. It is the job of the researcher to identify the proper variable, to identify the proper variable in the proper scale. Maybe you are doing a regression analysis. So for the regression analysis, each of the variables you need to define properly and you need to consider in a proper scale. That is very important. So unless and until there is a mismatch in this, if there is a mismatch in the scale, then that will lead to a faulty data entry and your result will be definitely inaccurate in that from that angle. Okay, so you have to be very sure about variables and the scales in which you are going to calculate, you are going to collect that data. Once you are absolutely sure about that, then only you can frame your questionnaire for primary, data collection, and accordingly the data will come. So after the piloting, you need first, after framing the questions, you have to go for a piloting just to test your questions. That okay, fine. The way I want to get the information, whether in the same manner the informations are coming or not. If it is not coming in the same manner, then you have to reframe some of the questions which are creating problem. Then after that, your questionnaire is ready for data collection purpose. Okay. When the data has come, then you are actually here to define the variables in the way, the same way you have used in your questionnaire or the schedule. Okay. You have to put the details here. That's why you have to define your variables in variable view. Then you have to enter the data, the values of the variables in data view. Okay, so you are actually starting your SPSS from this window, variable view. Once you have completed the different types of variables along with their descriptions, along with all the characteristics it is having, the scales and everything, then you can move to this particular window where the variable names will be here, and each of the cell knows that what kind of data in which width and in what scale is to be incorporated, has to be incorporated here in each of the cells. Okay, so earlier one was the first thing that will come. This, after completion of that part, this particular view will come. Now the variables here, the 10 characteristics are used to define the variable here. Type, width, decimals, level, missing, column, align, measure. See, is it there? Each variable must have a unique name of not more than 8 characters and starting with a letter. Okay, so it's not that you can put them in Excel. What we can do in Excel, we can put names, sometimes larger names, because the Excel sheet, it will accommodate that. But in case of SPSS, you have to maintain certain things. When you are putting a variable name, you have to write that variable name against which question you are putting what kind of variable name, because unless and until you are writing that, it will be very difficult to, capture exactly that which type of variable is reflected in which column. Okay, for that, each variable must have a unique name of not more than 8 characters and starting with a letter. Then try to give meaningful variable names. It's not that you are trying to get, the data on personal income. Don't put personal income entirely as a variable. PRS capital INC, you can put in this way. Okay, so that at least if you see the variable name, you can identify that okay, fine. This variable name is pointing to this particular question in my questionnaire, or this particular name is pointing to this particular variable. Okay, describing the characteristics, for example, age, you have to mention that okay, fine, age, this characteristic will tell that what kind of variable it is. Now linking to the questionnaire, for example, A1Q3 is going to be kind of a question which is linking to a kind of a variable which is linking to a particular questionnaire. Okay, so if you link your variable name to the question in a questionnaire for primary survey, then it will be very easy to understand that which question is having what kind of variable name. So it's better always, kind of rule of thumb we generally use for primary survey is that we take a schedule or a questionnaire and write down the names, variable names there on the blank questionnaire, so that we can identify in an SPSS data sheet that yes, this particular variable actually means this particular kind of question. Okay, pointing towards a particular kind of a question, so that there can never be a mismatch. Keep the name consistent across files. So a particular variable should be given a particular name in the entire process, so that you can identify this particular name belongs to that particular variable only. No other variables can be considered there. Then type means internal formats. It has to be given because the package needs to understand what kind of variable it is. Is it a numeric? Is it a string variable? Or it is a kind of a date? So accordingly, it will capture. And when it is going to, create tables or going to run a regression, then uh, it will do it accordingly. Okay, so that is a type is an internal format. The output format is comma, dot, scientific notation, dollar sign, or custom currency. These are the output formats generally. What is numeric? Numeric variables means numeric measures. Otherwise, sometimes it is codes. Likewise, let's say that uh, gender is a kind of variable which is important in a particular study. So we cannot write M or F in SPSS because it can only understand numerical values. So if we put a code in qualitative variables, like if it is male then 1, female then 2, or male is 2, female is 1, then it can identify that okay, this number of, there are out of 100 maybe 65 number of 2 is there and 35 number of 1 is there, and you can identify that okay, fine, I have given a code male equal to 1 and female equal to 2, so 65 number of 1 means 65 number of males are there, 35 number of 2 means 35 number of females are there. So codes are going to be very important where you have a qualitative data, but you need to incorporate that in a model, and that's why you are putting a code for that, which is a numerical figure. And then definition of the size of the variable. What kind of variable it is? You have given a name, unique name of the variable, but you have to, it's better to write the type of the variable it is, it's kind of a description of the variable, so that you can identify that fine, okay, this particular variable name actually means this type of variable, and we have identified this type of variable here. String variables contain words or characters. Strings can include numbers, but taken here as characters, mathematical operations cannot be applied to them. So, if strings are there which cannot be coded, then you have to put it in a way so that it can never be, it cannot be a very integrated or very important part of your entire analysis, because they are not going to be calculated. As SPSS is a kind of a software which always relies on the numbers, numerical figures. So the strings are something which cannot be converted into numbers, and therefore they cannot give you a result. Okay, so you have to be very careful about selecting the variables so that you can at least make a code of that, or can be used as a dummy. The maximum size of a string variable is 255 characters. That has been given in the package itself. What is date? The input format for date. This is known to all of us. Date variables must be defined, such as DD, MMYYYY, or MMDD, or MMDDYY only. So whether you are getting, you are actually interested about getting the full year, or month, year, month, date, year, or date, month, year, these are the different formats. The uh, if you're going to use the more than two dates, then you have to maintain a particular format. Either you are using this format or this or this. So you cannot use these two at the same point of time. That will not be acceptable. Maybe it will incorporate, but again, it will give you some kind of upon analysis, it will give you some kind of error message. Okay, your result will not be given there. Computers store dates as numbers from a base date. In SPSS, dates are stored as the number of seconds from 14th October 1582, 1582. So these are the reference numbers from where they will start calculating the particular date. Okay, so this reference number is also important, but as a I mean, as a user, we don't have anything to do of that. There's an example like create two variables. One is ID, the unique identifier, which will be the alphanumeric with a minimum of 8 characters. The other one is age, the age of the respondent measured in years, a discrete variable ranging between 10 and 100. So we consider in that way creation of two variables. Let's say ID and age. So if you create two variables, ID is a numeric, width is 8, decimals is 2, no values have been given, right alignment, measures are in terms of scales. Age is also another variable which is numeric, again 8 width, 2 decimal points are there, no values will be attached, no missing values will be there because that is available. 8 columns will be there, right alignment and scales, measures in scales. Okay, so this is the variable type. If you click on here, this will come. So you click on numeric, it will consider it as numeric. Put the value of width, this 8, that means 0.00 will be there, decimal place. Need to click here. Click on the string radio button and change the characters to the size of the variable. Here in this case, we consider 8. Then click OK. Click on the type column in the second row and define a numeric value variable with a maximum size of 3 with no decimal points. So we have given a variable 3, width is 3, sorry, the width is 3, numeric type of variable, and we have not given the decimal places, because if it is age, then we suppose that we will consider the researcher is considering age in terms of years only. And we have 10 years to 100 years is the maximum value, so that's why width 3 will be absolutely fine. Note that number of default values have been entered into the remaining columns. Default, these are the default values. Okay. So once you have given this, some of the default values have already been taken. So it has programmed in this way that if you are talking about some kind of variable, it's also a part of an artificial intelligence kind of thing, as per my understanding, that it can assess that what kind of variable you are talking about and what can be the related characteristics here, so that it will help the user to identify the variable from all corners available. Now, what are the levels? Descriptors for the variables. It can be maximum 255 characters and used in the output. These are the levels. Variable levels added. String numeric level is ID for ID, age for age. So it is putting the emphasis on levels. What are the values? Value levels are descriptors of the categories of a variable, generally, in terms of coding. Now there is another thing which is missing variable. See, missing variable. It defines the missing values. The values are excluded from some analysis. What are the options? Up to 3 discrete missing values, a range of missing values plus 1 discrete missing values. It can incorporate. Okay, so that is a kind of a benefit that it gives us, sort of a interpolation kind of thing. Click in the missing values column to obtain the dialog box below. Enter the values 999 for age. So if you have, on the other hand, if you have maybe the questionnaire is not containing a particular value for a particular variable, you can put a value which is in no way can match with the other values. So if you consider that the age for a particular respondent age is missing in the questionnaire in the answer script, then you put a value which is not possible as age. So you have defined that, okay, I consider minimum of 10 years old and maximum 100 years old. So that's why you are putting 999. You can put also 299 or 399, which is absolutely impossible for a human being to survive. So these are the values that you can put from your side. That if you have a missing value, if that particular cell is left blank, then the result will not come. Okay. So in that case, you have to put such a kind of a value. That value will never appear in a real life kind of situation. That's why you are putting 999. See the missing value added. Yeah. What about the columns and alignments? Column sets the amount of space reserved to display the contents of the variable in data view. Generally, the default value is adequate. Okay, so how long it will be? Because it is having a particular, the column is having a particular width. In Excel, if you keep on putting data, it will start accommodating the entire data. So if you write one thing, it will accommodate and the particular the column will start increasing. It will become a very fat column kind of thing. Here this is not possible. There is a given width for that. Okay. Generally the default value is adequate. Align sets whether the contents of the variable appear on the left, center, or right of the cell in data view. Numeric variables are right-handed, justified by default, and string variables are left-handed, justified by default. So if you are putting money value, currency, automatically it will consider that the currency will be a right-handed. By default, it will be aligned right-handedly. Okay, if you put age or if you put a kind of a variable which is which is a kind of a string variable, then it will automatically be left aligned. The defaults are generally adequate. In both the cases, the defaults are generally adequate. Then there was another thing which was measure, the levels of measurement, which was I was talking about that you are measuring your variable in which scale. Is it a nominal scale, ordinal scale, interval scale, or ratio scale? Your variables can be measured either of these four scales. Okay, nominal, ordinal, interval, and ratio. Now, in SPSS, interval and ratios are designated together as a scale, interval scale and ratio scale. The default for string variable is nominal. The default for numeric variable is a scale. See, now we are in the data view. Earlier it was on the variable view. Now you have incorporated all the important features of the variables we're talking concerned. ID is one variable, the age is the other variable. So these are the IDs. These are strings, therefore it's left aligned. And these are the ages, which are basically numbers, and it's rightly aligned. So now you are in the variable view, and you can see that this is going to be your data set. Returning to the data view, the first two columns headings will reflect the two variables created, ID and age. Here the first six observations have been entered. Six observations have been entered. So we have six people. From each of them, we have collected information on their ID and on their age that has been reflected in the two columns. Define the necessary variables and enter the following data: ID, drug, age, condition. Okay, so we have four of them. What kind of drug they consume, what is their ID, what is their age, and what is their condition. See, relapsed, relapsed, recovered, recovered, relapsed, recovered. Now you have, after entering the data, it's a question of saving the file. So unless and until you save all what you have done till now is all in vain, goes in vain. So you have to save the file, and the file must always be saved in order to save the work that has been done today. You go to file and save, move to the target directory, enter a file name and save. So this is very easy, and the way we save in Excel, the way we save in Word, it's the same kind of thing for saving. Okay, but remember, the file that you are saving, unless and until your machine is having SPSS software, you are not being able to open the file in a particular machine. So you have first machine where SPSS is installed. You have done all these things, data entry, the variable descriptions, entering the data, and you have saved the file. Now you are carrying a pen drive in which this particular file is there. You are trying to open the pen drive in a second machine where there is no SPSS software installed. Then you are not going to open that particular file because it's not at all possible without that particular software. This is how it looks like. Exercise, we've given EX1 as the name. That is all about the very basics of data entry and uh, kind of data savings. Okay, the very basics of SPSS that we thought that you should know this. Okay, now can we continue a bit for 10 more minutes?
Yes, sir. We are able to continue.
Okay. So as I said, that instead of you know drawing a diagram or creating a table, let's go to a kind of analysis which is a little more complicated, but little more down to earth. Okay, which is a regression analysis. Can we have a very quick before this? Am I visible, or the slides are visible only? Hello. Is it only the slides which are visible, or I am also visible?
Okay, you are visible.
Slides are not visible.
Yeah, slide also.
Slide is visible. I am not visible. Okay.
Yeah.
Let me ask a question. What is regression? What is regression? See, we are interested about the complex nature of the society, and we know that if we talk about the society, it's not only one particular variable which can change our life. There are combinations of variables. Okay, so a real life situation also really talks about the variables which are related to each other and are going to affect or get affected by a lot of other factors. Okay, so we thought that just to see what exactly happens. Real life situation involves complex relationship between or among variables, and the researcher in social science need to address this complex relationship using structured models. Okay, we are going to express or represent the relationships in terms of a framework, structured framework, that is a structured model. It is not only the degree of association between or among the variable is important. We are not only interested about how much related these two variables or these three or four or five variables are, but we are interested about the cause-effect relationship. So if there are changes in one set of variables, whether the set of variables change is going to affect another variable, the dependent variable. Okay, so that is also important. That is very important. And regression is a statistical model that explains such complex relationship. That means if there is a variation in a set of variables, whether those variations are going to affect the variation in one particular variable which is related to the other variables concerned. Now, regression comes under a framework with a certain assumptions. The simplest regression model is known as a simple linear regression model, or sometimes it is known as a classical linear regression model also. three types of data may be available for empirical analysis that we generally use for regression analysis. It's a time series data. When a time series is a set of observations on the values that a variable takes at different times, such data may be collected at regular time intervals. That means one particular entity will be captured for a prolonged period of time to measure the performances and efficiency. There is another type of data which is a cross-section data. Then cross-section data are data on one or more variables collected at the same point of time. That means maybe we are interested to compare different entities on a particular variable, and for that we are collecting the data from different entities on that particular variable at the same point of time. Okay, that is a cross-section kind of data. Sometimes time series data or cross-section data are very small in nature. So in those cases, we may go for a pooling of those data, which is known as a pooled data. The pooled data are the containing elements for both time series and cross-section data. And a very important type of data type is a panel data, where a special type of pooled data in which same cross-sectional unit is surveyed over time. Okay, so if we are asking questions on particularly 3, 4, or 5 states over a period of time, then the combination of those 3, 4, or 5 states in the same for the same period of time, one after another, that gives you a panel data. And those actually gives you the kind of regression which is known as multiple linear regression, MLR. Simply, it's a method for studying the relationship between a dependent variable and two or more independent variables, the purpose of which is prediction, explanation, and theory building. Okay, so this is a kind of a model which is going to be a predicted model. It's a kind of a predictive model where this y depends on a, x1, x2. There are n number of variables. Okay, so the MLR estimates the relative importance of several hypothesized predictors. These are the predictors. Okay, this is predicted. MLR assesses the contribution of the combined variables to change the dependent variable. This multiple linear regression model actually assesses the contribution of these variables x1, x2, x3, x4, and xn, and so on the change in this predicted variables. This one dependent variable, the design requirements for MLR is the one dependent variable is a criterion, two or more independent variables are the predictors or explanatory variables. Now, if the sample size is greater than or equal to 50, that means at least 10 times as many cases as independent variables are there. So these are the parameters. Sometimes you have to remember, or you have to know that always the number of observations has to be larger than the number of variables you have, or the number of parameters that you have. That is going to be very, very important. Otherwise, the result that you will get will definitely be a faulty result. Now, the variation may so happen that the total variation in the dependent variable may be due to the predictable variation by the combination of the independent variables. So you have defined the variables which are independent variables. They may be varied, and that variation may lead to a total variation, part of the total variation. Apart from that, there are unpredictable variations. Okay, so you can remember that after this there can be another term which is an uncorrelated error term. Okay, so the variables that you have incorporated in the model, maybe there are one or two more variables which has not been incorporated in the model, but they also have some small effects on the variation of y. So that is the unpredictable variation. There are certain basic assumptions of this multiple linear regression model, that is independence, normality, homoscedasticity, and linearity. Independence means the data of any particular subject are independent of the data of all other subjects. So whatever data you are having on a particular subject needs to be independent on related to the other subjects. Okay, so these data should be independent to each other. That means there should not be any kind of overlapping in that way. Normality tells in the population the data on the dependent variable are normally distributed for each of the possible combinations of the level of the x variables. Each of the variables is normally distributed. That means the variables that you are considering, you are assuming that they are normally distributed. There is normal distribution. So then only you can go for standard statistical exercises. Otherwise, you have to go for non-parametric exercises. Homoscedasticity is important. That is, in the population, the variances of the dependent variable for each of the possible combinations of the levels of the x variables are equal. So they are having equal variances. The variance will not fluctuate over time, over the entities. Okay. And linearity means in the population, the relation between the dependent variable and the independent variable is linear when all other independent variables are held constant. So if you consider this particular well, the relationship between y and x1 is linear when x2 up to xn are keeping constant. Y and x2 has to be linear when x1 and other variables are keeping constant. Similarly, y and xn, the relationship between these two has to be linear when others are keeping constant. That is the meaning of linearity. This is a, the comparison between simple regression and multiple regression. That's not very important. One dependent variable predicted from one independent variable, and multiple variables are there. Generally, R-square is the proportion of variation in the dependent variable and the predictable from x variable. In this case, R-square is the proportion of variation in the dependent variable y, predictables by set of independent variables. You have so many variables here, k number of variables. So your R-square is basically known as a goodness of fit, the model that you have created or constructed. Whether the model is acceptable, is a very good or not, that will be determined by the value of R-square. Okay, the value of R-square lies between 0 and 1. So if it is very close to 0, then the model that you have constructed is not much acceptable. If it is close to 1, then the model that you have constructed is acceptable. The same thing that I have told earlier also. Now, this thing I have mentioned earlier when we were talking that variables in the model. One approach is to how to select the variables. One is to perform the literature review and examine theories to identify potential predictors, thus building a theoretical value. This is sometimes referred to as the standard regression method. Second approach is to examine statistics that show the effect of each of the variable both within and out of the equation. So the variables which you have mentioned and the probable variables which you have not mentioned should be incorporated in the uncorrelated error term. Okay. The output is the following notions are essential for the understanding of MLR output, that is R-square, adjusted R-square, constant term, beta coefficients or B coefficients, F test and T test. I think moreover, we'll just keep this and go to significance tests, F and T test, R-square. Yeah. Here, when you take a data set, then from analysis, it's not visible here. From analysis or analyze, go to regression, then go to linear regression. Then you will get this linear regression dialog box. Here, all the variables have been mentioned. Okay, so select one particular variable. The kind of dependent variable you are considering, you have to put here. The independent variable from this set of variables, select each of them and then click on this button. It will be it will go here on this independence variable. Then linear regression options will be there. Generally, we use a probability of F at 5% level and removal after 10% level, 0.10, and generally include the Constantine equation, exclude case listwise. This is going to be the result. It is the descriptive statistics. From the entire data, you will get the descriptive statistics. And this is going to be your model where these are the coefficients. Intercept term is this. This is the standard error of the intercept term. This is the coefficients. These are the t values. And this is at 95% confidence level. Okay, now the model summary tells that the value of R square is 0.13, that means only 14%. Okay, and the ANOVA result will be available here. See, the predictors have been given, the weight of the subject, POC, red blood cells, etc. This was a study which was conducted related to, drug use, a kind of a medicinal drug use, and on different types of other human physiology related variables. And the dependent variable was the days in hospital. So this particular days in hospital was regressed on all these variables. So this is your result will actually give you everything. Okay, the model summary from R square you can have an understanding, or adjusted R square you can have an understanding of whether the model you have constructed is acceptable, at what level acceptable or not, and the ANOVA that is also available. What does the ANOVA result mean? You can see in any kind of standard statistical book about the ANOVA. It's not related to SPSS or any other statistical software. I think that was basically what we have, and you are confused enough, I guess. Thank you so much for, I guess, it was in hurry, definitely, because the time was a little short, but I have tried to show you, as I said, that a little complex thing, because it's very easy to draw diagrams and tables, and you can use Excel for that also. So that's not a big issue. I thought that how this regression is used, because particularly I'm from a social science background, so for us it's very important to capture the relationships that they're existing among the different variables. Okay, thank you again. Thank you so much.
Thank you, Samrat sir. Really, it is a very nice presentation because I am also following your talk now. I am just sitting here. So for the audience, I feel that they can use this concept. At least they can start up using whatever you taught now. So thank you very much. That I think you have not taken lunch today in your hectic schedule. I can understand that. Thank you very much, sir.
Thank you so much. Thank you so much.
Samrat sir, thank you very much.
Thank you so much.
So thank you, sir.
Thank you.
Thank you, sir. Thank you.
Okay. So for audience, I have shared feedback link. Please fill up that feedback. And tomorrow at 2 p.m. we'll meet again. So check the schedule. Tomorrow we'll cover LaTeX, but in online mode. The title is Cloud-Based LaTeX Editor for Technical Writing using Overleaf. Thank you all. Bye.